Okay, so some examples. Number 14, y equals the inverse sine of -1. So the way this works is I go to my unit circle. I know that sine can only exist on the right-hand side from -pi/2 to pi/2. So I'm going to find where my y value is -1 and the angle is my answer. Okay, so I'm looking at my unit circle. So the sine being equal to -1 is down here at what is normally 3 pi/2 because y value is -1. However, I have to remember that it's from -pi/2 to pi/2, so this is going to be all the way down here at -pi/2. So the answer to this is -pi/2. (16) is y equals the arc cosine of 0. So this is the other way that it can be written, but it means the exact same thing. So I know that cosine can only exist on the top. So I'm going to find where cosine is equal to 0. So I'm looking for the x value being equal to 0. So that's up here. And I look for that angle value, and that's pi/2. So my answer is pi/2. So this is basically the opposite of what we've been doing. We've been given an angle value, and we're telling what the x or y coordinate is, but now we're looking at the x or y coordinate and telling what the angle that produces that was. And this would ultimately allow us to be able to solve trig equations. Um, 18, y equals the arc tangent of -1. And I'm going to also point out that number 20 is y equals the inverse tangent of -1. These are going to have the same answer because they mean the same thing. So just for you to visually see that. So I go to my unit circle and I'm looking to see where the tangent value is -1. Remember, tangent occurs on the right side. So what angle value produces a tangent of -1? Only looking at the right side. Seven pi/4, but I have to remember that it's from -pi/2 to pi/2, so how could I write this in terms of a negative angle? So normally, let's do it this way. So if I have my circle, I've got pi/6, pi/4, and then I've got pi/3. So when I go down, I'm going to have -pi/6, -pi/4, and -pi/3. And then all the way down here is -pi/2, and this is pi/2 up here. So this is what would have been 7 pi/4. So the answer to this is going to be -pi/4. So I would make sure, because obviously on the unit circle I give you, this isn't going to be on there. But I would make sure you look over that for sine and tangent, because they have these negative values here. And obviously this one here is just 0.
Cosine you don't have to change.
No, because cosine's on the top, so it's just all the top values from 0 to pi. So yeah, cosine is just your normal unit circle. Sine and tangent, the top part of the right is normal, but the bottom you'd have to make them negative angles instead. And usually a question on the quiz / test is going to be, where do the inverse sine, cosine, and tangent exist? And so when I ask you that question, this is what I'm looking for here, are these pictures. So, that way I know that you know where it is. And then I'll like check that for you so that you make sure that when you're doing your answering the questions, you know where it is so you don't get confused. So make sure you look over those. 22. Y equals the inverse sine of root 2 over 2. So sine exists on the right. So where is the sine value negative root 2 over 2? What angle value produces that? Angle. What?
Pi.
Yeah, pi over 4. So sine is root 2 over 2 here, and that angle is pi over 4. Um, 24, y equals the inverse cosine of negative 1/2. So I'm going to look at the unit circle and see where cosine is equal to negative 1/2. And remember, I only care about the top on cosine. So where is my x value negative 1/2? 2 pi over 3. (26) Y equals the arc sine of negative root 2. So, where is sine negative root 2?
1. So it'll be 5 pi over 4.
So where would the y value be negative root 2? Is that something we have on the unit circle? Remember, with sine, I can only look at the right side anyways. So let's check the calculator and see. So it's not a value that we have on the unit circle. So on the calculator, if you wanted to type this in to check, or if it was a calculator portion of this, what we do is, if you look at each of your trig functions along your calculator, right above them is each trig function raised to the negative 1, which means the inverse, which is why I show you the notation, because this says arc sine, but when we look at it and plug it in, it's going to have to be with as inverse sine. So you hit second and then whatever trig function it is, so sine, and notice it brings up sine to the -1. And then I'm going to type in -√2. And notice it produces a domain error. Okay. This means that it does not exist. So that means there is no inverse there. So we just write D and E for does not exist on that. So if there's one that's not on your unit circle, plug it into your calculator and see what happens. And more than likely, it does not exist if it's in this section. And you would need to be in radian mode to check these, just to be clear. $38. These ones say to do them in degrees, but once you go past this class, it's not very often that we use degrees, so we're just going to keep it in radians. So modify instructions to radians. So it says that theta is equal to the inverse tangent of √3. What side am I looking at for tangent? Like top or right, basically.
Right.
Right side. So I need to see where the tangent value is equal to √3. And what radian value is that?
Pi over 3.
Yep, pi over 3. We basically already did that one, so yeah, we did. Okay. All right, feel okay on this? Feel like we're ready to try it? All right. Then 13, 17, 21, 23, 37, 39, and 41. Plus the problems from the last section. I think we should try to quiz on the last section and this section on Wednesday. But we'll see how this goes, and then tomorrow we'll decide for sure if that's what we're going to do. But let's tentatively plan for that at this point. So there's about 15 minutes left. I think you could probably knock out all these problems from today.